And here we are again, I do believe. Let's
all right.
Check. Yeah, I see you all coming back. So again, I will just give you a minute to type in the chat and confirm that you can see me and you can see Greg and we're ready to go. And yeah, had some great talks so far. Have you been following them, Greg?
I have. And it's great because, you know, it's the theme today has been databases and REST APIs, and so this is a database with a REST API.
Yeah, it's been a database fest today. Right, good. We seem to be good to go. So, Greg, I'm going to hand it all over to you, and if you want to run your videos, you remember how to do that, and I will just.
Well, hello. As I was just saying, you know, today has been about databases and REST APIs. I'm going to talk about CouchDB. CouchDB is a database, a NoSQL database that uses a REST API as its interface. I think CouchDB is sort of perfect for LiveCode. And it has all of the same qualities that LiveCode has. It's really easy to sort of start getting into, and then has some nice advanced functions that make it more powerful. And so let me start off with the introduction to it, and hopefully we'll have some questions.
So Couch is an acronym for Cluster of Unreliable Commodity Hardware. It can easily be run on a single node, but its ability to be run on multiple nodes, and when I say that I mean low-end nodes, it can really shine. It's horizontally scalable. When you look at something like a SQL database where you need to increase RAM, you need to increase storage space, Couch and a lot of the other NoSQL databases are designed to be multi-node systems. High availability is another one of its key features. Documents don't get locked out in the same way that they do with SQL databases. Of note is it's designed for reliability even on failure-prone hardware. So you can set up a multi-node system, and as long as everything is configured correctly, you can lose multiple nodes in the system and still have a reliable, available database. So a little more about what is CouchDB. Again, it is a NoSQL database. That is a very broad topic to mention, but it basically means that it is a database that is not tabular nor relational in nature. So there are several subtypes of NoSQL databases. CouchDB falls into the category of document-oriented. It refers to the fact that all records are saved as some form of document. Other document-oriented databases include MongoDB, which is one of the most well-known NoSQL databases. And the data is stored in JSON. So each document in the CouchDB is a JSON document that is just edited and re-uploaded. It is schemaless. You are not set to any particular design. You can have documents of multiple types within the same database, and we'll look a little more into that in a few minutes. CouchDB exclusively uses REST API for interaction, which makes it nice and simple to program into LiveCode. The main query system for CouchDB is called MapReduce, and it's written in JavaScript. It requires a bare minimum of JavaScript. It's pretty easy to use, just some basic templates that you'll find around. And everything is self-contained. So a single document just has one source with all of the information available. So just as a way of comparison, looking at a traditional relational database, I have a table of musicians. At the top, the rows list the schema, where I have some sort of ID number, I have a name, stage name, some other information. And this has to be designed ahead of time. So a database is created, the schema is set at the beginning, and if I want to add some other information here, let's say I want to add in instruments that these people play, and I want to include bands that they're in. I can either add extra columns, or I create additional tables, and those tables get linked. So the ID number links both of those tables back to the initial table. And then we see what we have for an SQL command. So this is just a standard select command where we're looking for individuals who died, and we list out what their stage name is and what year they were last alive. And that is a super simplification of what relational or SQL databases might look like. CouchDB, on the other hand, would look like this. Even though the order of the fields is the same as it was, the order is actually irrelevant. You also notice that instruments and bands are included as arrays and are part of the main document. There is no linking, there is no extras. Everything here is self-contained. So on another record, we have a person who is not dead. I have listed that the year of death is null, but that actually is an optional choice. If a value is null, it can also be completely eliminated. When you have a relational database, that value still ends up as null. And again, because of the schemaless nature of CouchDB, additional information or miscellaneous facts or anything else can be added at any time. At no point do we need to tell CouchDB that we are adding new fields. We just add them. And again, they don't have to be static or standard across any other documents. In fact, you can create documents in the same database that have nothing to do with the previous documents. Whereas the previous documents were all musicians, here we have a band and a record company, and neither of them have fields in common with each other or with the original fields in the musician database. So a MapReduce query, real quick, looks like this. The first one is pretty much identical to what we looked at with the SQL query and produces the same results. The second one is the reduce version of the MapReduce query, and that takes and counts the values that we specified. In this case, it was nationality. So that is a count of nationalities across the database. And additionally, you can, using a little JavaScript, create more complicated map functions. So in the other examples, there was a null listed for someone who didn't have a stage name. I have a couple of functions in here. For starters, I am calculating the approximate age at which they died. I am then checking to see whether or not they have a stage name listed. And if they do, well, then we use that. And if they don't, we use their real name. And then, as long as their age at death is greater than 0, it's going to release that information. And there are the results. So additionally, as of CouchDB 2.0, which came out in late September, there is another query system called Mango Query. Mango is based on MongoDB's query system. With MapReduce functions, you need to design them out ahead of time. Whereas Mango queries can be posted to an endpoint in the database, and it looks a little like this. It's a little more flexible than MapReduce. It's not quite as fast, but it gives similar results. So real quick, how CouchDB is different from relational databases that you may already be familiar with. CouchDB uses documents instead of records, rows, tuples, or whatever the database calls it, and it uses key values instead of columns. They are self-contained documents instead of linked and joined tables. CouchDB uses multi-version concurrency control instead of locks, and this increases availability. So whereas an SQL database might lock a record while it's being changed or edited, CouchDB will make the current version available until the newest version is finalized. It's schemaless. The data does not need to be predefined, and it can be altered. You are uploading documents instead of inserting values. Design documents with MapReduce instead of SQL, and of course also Mango that we were looking at briefly. One way I like to differentiate the two types is that with a relational database, you need to know what your data will look like. That has to do with the schema versus schemaless systems. However, with CouchDB, you need to know how you will use your data more. Now with Mango, there is a little extra flexibility, but otherwise, the queries that you plan on with your database, you sort of need to have thought of in advance. And of course, it's also worth noting that relational databases have been around a long time, and they're ubiquitous. NoSQL databases are still relatively new. CouchDB's been around for a decade or so. So let's see CouchDB in action. Okay, so here's a quick demo app. In this text box here, I am going to use raw JSON, and then I'm going to have it converted into an array and put into this data tree over here. And so I have a command button. Okay, I've got three commands in here. This is the first one. So the first thing I got to do is I've got to declare some variables with the URL, the name of the database, and then authorization. I've created a user called LiveCode with a password global, and I have to set my HTTP headers. That's going to include this authorization string as well as some general content information. And now I'm going to pick a document, and I'm going to construct a URL and then put the URL into the result. And the result then just goes into the field, and then I change the tree to an array of that. And simply I'm just going to click execute command, and there we are. Here's the raw JSON, and then here is the data in a tree format. So that's how simple it is to get a Couch document. Now I'm going to put a document. I'm going to pause real quick while I just type in something. Okay, so I added a quick note here. I'm just going to switch over to Photon, my web interface, and this is the record that I'm editing right here. Okay, I am going to uncomment my put command and going to comment out my get command. Okay, so now when I click execute, what I got is confirmation that my put command worked. And if I switch back over and refresh, I have my additional notes down here at the bottom. And finally, I'm going to comment this section out. I'm going to pull up the results of a design document. In this case, I have the data scan as the document, age of death is the view name that I'm looking for. Okay, and I get my results here. And I can look at the same results directly in Photon. Set it up as a table. So that's the simple it is to work with CouchDB in LiveCode. And then in a minute we'll get into a library that I've been working on to make things even a little simpler.
Okay. So that is the basic introduction. Sorry for going through it really fast, but you know, my first couple of iterations of that video were about, you know, an hour long or so. So we got it down in size. Let's say, are there any questions now? I don't think so. One thing I didn't really cover was installation, but installation is pretty simple. For Windows, it's, you know, download and unzip and copy to your program folder. Apple, for Mac OS, it's download, unzip, and install. And with Linux, there's a couple of extra steps, but for the most part, it can be done with apt or yum or whatever you might need. Anyhow, I guess if there aren't any other questions at this point, then we'll jump to the next video where we start talking about the CouchDB library that we've been working with.
So I want to introduce Daybed, which is CouchDB for LiveCode. It's a library I've been working on for a while. It's available on GitHub. CouchDB has a long history of add-ons and faces that use puns on couch. So I chose Daybed, but sofa, futon, and a bunch of other things are already taken. Several sections of commands. I'm going to go over the basics, but first I use a modified version of fastJSON that is included and used by default with Daybed. There are three main reasons why I recommend using fastJSON over the built-in functions. For starters, mergejson only creates JSON arrays where the numeric keys are sequential starting at 1. So if there's a gap, it will not create a JSON array. So I've been working on it from my end, trying to make it more compatible. The next reason is I've had difficulties with mergejson in Ubuntu standalones, and so at my job this is a major issue for me, as all of our stations run Ubuntu. And lastly, I also find using a JSON library easier with LiveCode Server. That being said, you can use a different JSON library and just specify it in the... So these are the main functions of Daybed: couchget, couchput, couchpost, couchdelete. Obviously those are the REST functions. They each take nearly identical parameters. The only differences are that couchget and couchdelete specify a document ID, whereas with put and post you have to specify the entire document. So those parameters are first is pfunc, which is the function that's going to be called. All docs and find are examples. dbdoc and ddoc are not actual official functions. They're simply what we'll use to get, put, post, or delete a database document or design document. By functions, this is what I'm referring to. This is the CouchDB API reference, and these are all of the functions that can be put into pfunc in order to act in some way on the database or a document. So the URL has to be included, and that's the port as well. Port is usually 5984. Database name, if applicable. The only time it's not applicable is when you're configuring CouchDB or adding users. So again, pdoc ID and pdoc. Pdoc ID is the document ID that needs to be called. pdoc is the document that needs to be uploaded, and it should be in an array. The library will convert it to JSON for the upload process. pparams is an array with any URL parameters that need to be added. For example, I mentioned alldocs up here. Alldocs just gives you a listing of all the documents in a database. If you put include documents equals true, that gets added to the URL as a parameter at the end, and that will then download all of the document information as well. And then poptions is an array. This includes everything else, header information, authentication, design doc specifications, so anything basically that's not covered anywhere else. So here I am back in my demo program, and I am going to execute a daybed command instead. So the library is already loaded. Here I have, again, the URL and the database are specified, and I have the authentication string, which is going into toptions. Authval stands for authentication value. And then to get a document, I'm just doing couchget doc. This is my URL, database. This is the document ID, and toptions is at the end. I don't have any parameters that I'm specifying. And again, the same thing where it's going to put it both into the tree view as well as the field. So I click execute. There's my JSON, and here is all the data. Okay, so I'm going to make a quick edit over here. I'm going to pause. Okay, so I've added an additional note here. Okay, I have my put command ready, and now I'm going to execute it. And there we are with the updated revision number. If I switch back over to Photon, the web interface, see, this is what it was originally looked like. Now if I do a refresh, I have my note here, and the revision number is increased by 1. And so lastly, we're going to look at the design document, and this is again the same age of death data scan document. I'm going to go ahead and execute. And again, I have the same results that I did before. So that's the real basic overview. The exciting part is the synchronization commands, which we will talk about momentarily.
Okay, so that's an introduction to the library. There's more to the library than just those 4 basic commands, but those 4 basic commands do everything that you need. I've added some more commands that do certain things quicker, because once once you have certain things set, like what your URL is, and if you're going to be using the same database over and over again, instead of having to re-specify it each time, you can put in sort of quick commands to just re-access the same information. But the big thing that I've been working on, and I use this in a lot of the apps that I work with, is a synchronization process. So it is going to save locally information and sync it up to CouchDB wherever it happens to be installed. And that is what the next video is about. So just checking real quick. No questions at this point. So I'm going to go into the sync process now.
So we're going to build a syncing notes app. It's going to be loosely based on SimpleNote, which uses a backend system that is similar to CouchDB. So first I just want to briefly gloss over the built-in functions in Daybed for synchronizing. All of these functions begin with dbdb for Daybed database. dbdb stack load is a command that should be in the OpenStack handler. It's either going to open a save stack in the background and then it copies the property set to DaybedDB as the property set on the local stack. And if it doesn't exist already, it's going to create it. The first two parameters are the only ones that are required, which is a file name and a stack name. There is a default location, but that can be overridden using the main folder and subfolder parameters. So the dbdb local new user is a Meteor command that is going to create a database for the user. It's going to insert a design document that helps in the syncing process, and it's going to create a new user in the users database in CouchDB. So the required parameters, you need to include the URL that includes the port number of the CouchDB installation, the person's username, the person's password, and then pauth is a base64 encoded string of an administrator's username and password. This is the only time that that's going to be needed. One thing I'll note here is that I've also set this up so that you can use the same database for the same user for multiple apps. So the prefixes are there so that you can either give a database a different name or prefix the ID numbers in the database, depending on whether you want multiple databases or one database. Also, conflict resolution. By default, the server always wins in conflict resolution, but you can set it so that the local copy wins. And then there's also an option for duplicate, which means if there's a conflict, there will be two copies then of whatever document you've got. And this is the rest of the commands. The stack save command saves the external stack that was loaded earlier after having copied the property set over. dbdb local sync doesn't require any parameters. It just begins the synchronization process of the local data with the database. The last three commands are for setting, getting documents from the local property set. So the local set doc saves the document to the properties and flags it for synchronization, either as new or as having been altered. The delete doc does similar. You just send in the ID and it's going to flag the document in properties as deleted. And then get doc just loads the document from properties. And I'll be using all of these commands in this app. Okay, here's my CouchDB instance. Just the one database so far. And this in general is SimpleNote. I've got my note list here on the left. I've got a note on the right. I've got tags. I've got buttons. This is what I'm going to try and emulate. And here it is. Over here I've got my notes list. This is where the notes go. This is where the tags go. This is the tag picker right over here. And a little menu bar. Before I sign up, let's take a quick look at the stack script. So in my OpenStack handler, I've got the start using Daybed Demo, that's library. I set the custom property set to Daybed DB, which is where I'm going to be saving all of my local data. And here is the stack load command. I've got a simple file name and a simple stack name. And then I'm immediately running local sync. On my close stack handler, I've got a compare note, which is down here. We'll go over what that looks like. And then, of course, I do a save of the save stack. So the compare note command, which gets used a lot, looks at the current state of the note in the note editor, and if it's different from the currently saved version, then it is going to use the setDoc command to flag it for synchronization and update it in the local property set. I'm not going to go into detail about the last couple of commands, update note list and show note list. Basically, these are just commands that take the document list, which is by key, and sorts through it and creates a new list, which is an array that has note title as the key. And basically this is just something to make it simpler for displaying the note list that's on the left side. So let's look back at the sign up button. So the sign up fields, I have a username, email address, and then a password and a confirmed password. This is the mouse up command here. I'm specifying the URL and the authorization string. I'm creating a notes prefix, so the database will begin with notes. I'm going to pull in the user's information from the input and verify that the person filled out what they did, correctly here. And then I'm going to run the local new user function, which will create the new user and the new database. And I'm going to simply do it by clicking sign up. And if I switch back to Safari and do a quick refresh, here is my notes database. If I click into users, see here is the new user, fprefect. And then there's one document in the database now, which is just simply this design document that gets automatically added by the program. Okay, let's look at this action bar here real quick. I have my new note button, which just creates a blank note. It starts the process of putting the data in the property set, but it waits for there to actually be a real note before the actual doc is set. I've got the sync button, which does exactly that. It starts the sync process. The delete button uses the db local delete doc. It takes the ID number and flags it for deletion. The data button is actually just a quick Uber function which lets us look at what the entire property set currently looks like. Right now, since there's no notes, the only thing that exists here is the settings, which has my authorization string, and all of the other information that was either by default or set up in the new user function. So I'm going to go ahead and create a new note. And I'll just give it a tag of MISC. See now that it shows up on the list on the left, and if I open up the data, I have now this note here, which is currently flagged as new. and all of the information is currently in it. This is just what the notes list looks like, so it has title and ID number, since down below it's ID number and then title is within it. And the current note, this is what's going to always be compared with whenever the compare note takes place. And if there's any differences between this and the note in the editor, it's going to be flagged. So I can switch back and forth between the notes with this. I've only got the one tag, so it's not really going to show you much here, but I can filter based on tags. And now I'm going to pause and create a bunch of extra notes so that we can see the syncing process. Okay, so now I've added a bunch of new records. Now I can go ahead and actually switch to different tags at this point. But I'm going to go ahead and click sync, and then I'm going to switch back over to my browser. If I do a quick refresh, you see now I've got more documents, and these are all of my notes that I created. And if I go back to our data view, you can see that the notes now have a revision number attached to them. And that's the revision number that will be used during the comparison. And then up in my settings, I'm going to have a last sync time. Okay, now I'm going to pause and I'm going to make one more change here. Okay, so I'm directly in Photon right now. I've made two changes to this note. This is second note, and I changed the text to say updated note, and then I changed the last sync date to a time that's after the most recent sync. So this is as if I was using the same app on a different application. I synced it there, and now this is out of sync with my local app. So I'm going to save the changes here. I'm going to switch back. Again, this is the second note. Let's see, it's revision number 1. So I'm going to go ahead and sync it again. And you see second note now says updated note. When I pull this up, the revision number is number 2. So I've synchronized in both directions. And then the last thing is just simply I'm going to delete the garbage notes that I created. I'm going to go ahead and sync them. Now what that's going to do is here in the data, it's going to be revised again. Now I have the deleted true flag. Back here on the database, again I have the same thing. I've got the deleted true. Now, the record itself is not actually deleted from the database. I'm working on a purge system to accomplish that. But that is the syncing process in a nutshell.
Okay, so that's the synchronization process as it exists now. I have more work that I'm adding to it, a few other methods of syncing in addition to a per-user database. Let's see, I don't think there are any questions at this point. So I'm going to just take the last few minutes to show you some other examples of CouchDB in action. And let's see if I can share my desktop without... Okay, that's the live notes. This is an app planning board for iOS that I created. It's available on the App Store. Everything here is customizable, and this is also my sort of plan of action for the Daybed library. But the width of the columns, the color of the columns, the number and label of the columns, how the cards are set up, all of this is customizable, and all of it needs to be kept track of. And in order to also allow it to be used on multiple devices, it has to be synced. So all of this information is available in an array in the application, and this is what it looks like in a nutshell. This is the entire document for this planning board. So all of this information is synchronized here. My title, this is the settings for the columns, cards, card labels, the color and size of the cards, and then the actual cards themselves. So the different tasks that I've created. All the information is self-contained in one single document that gets synchronized with the database. Let's see. 1 second, let me just, oops. Okay. Okay, so I've got a question. Have you been using CouchDB on a mobile platform? Which was sort of what I was just going over. So that is...
you need to get your camera back on as well. There we go.
Oh, okay. Sorry. Okay, so CouchDB on a mobile platform. So yeah, that's what I was just showing. That application, I mean, I was showing you in LiveCode, the LiveCode stack, but it is a fully compatible with iOS and Android because it's just a REST API. Anything that can be done in a REST API, anything that we can done via HTTP can be done with any platform. So obviously, one note would be when you're setting it up for iOS, you do need to have your security certificates in place, so it's got to be an HTTPS connection, but it works very well. So I was going to say, are there any other questions at this point? I think. How are we doing on time?
You have got 9 minutes if you really want them. So, yeah, I find that very intriguing, I must say. I find it very difficult to get my head around the idea that you can have a database that doesn't do this. So.
It's funny because I was looking for something different. I don't particularly think of things tabularly. I've never liked tables and linked tables. I was taking summer school 2, which I'm assuming is probably still available to be signed up for. But we were talking about REST APIs a little bit in that, and that's what sort of started looking around for different. I hadn't even heard of NoSQL databases at that point. So if you are interested in learning more about CouchDB, besides, of course, just asking, I have a thread about CouchDB in the databases forum, and you can ask me anything that you need, or if you want to get started, I'd be glad to help out. I also have a course on Udemy, which I have a link for here. Hold on a second. There we go. I'll post that on the forum as well. But yeah, you can do a lot with it, and like I said, you can begin very small and very simply, and there are a lot of advanced functions that you can sort of develop as you go along. Also, Herman's asking, where's the pink? No pink today. It's sometimes there, sometimes not. Sort of depends on what's going on my schedule. Did I misunderstand you, or did you say that you needed to upload data as an array? If it is so, why not upload it as JSON? The way it's set up, you send the data to the command as an array, and it will convert it to JSON for you. Theoretically, I guess I never thought of making it so that you would send it as a JSON directly, and there's no reason why I couldn't make a change in that. I'll make a note of that. What data analytics are included with CouchDB? I guess I'm not sure what you're looking for there. Let me. Yeah, I'm not sure what your question's asking. If you're talking about things related to the oh, can you? Okay, can you? I'm sorry. Data analytics. Yeah, I'm not. I guess I'm not totally sure what you're asking for, so I don't want to just start speculating. Can you use encryption on both ends? Yes, you can. I need to spend a little more time to be able to actually give you details on that. Chinese characters. That's sort of a yes and no kind of thing. Everything it needs to be in UTF-8 format eventually. So when it gets encoded, it'll be there in some form or another. Everything that goes into the document ID and the database name has to be URL friendly. It has to be something that can be URL encoded. So in some ways, it's sort of a yes and no kind of thing. What actually is going to appear in the database wouldn't actually be Chinese characters, but at the same time, they'd be there as some sort of encoded value. Oh, I see. So ability to graph data stored in the database. I'm going to say not really. What you can get from CouchDB itself is largely either just the data or reports that you create about the data. So anything else is something that you would have to basically sort of more or less add along as you want. Depending on exactly what you were hoping to do, it may or may not be simple. But with MapReduce, there's a lot that you can put in place. I hope that answers the question. And yes, they say the course is 4.5 hours, and again, that's trying to condense it down into 50 minutes was difficult for this. So And I'm not done with it yet. I mean, just 4.5 is where I'm at this point. But they've just released version 2.1 about a week ago, and there's changes, and those need to get it included in there. So, any other questions?
Well,
I'm on time.
I know you are the first person today to end on time. Go figure. That's amazing. Well done. That was really interesting, and I think, like Herman mentioned, that's one to view again and study, because it's so different that I'm not getting my head around it. Very interesting. Thank you very much. So I am going to end this one, and we have up next, last but by no means least, we have Jackie Landman-Gay, who is going to
Hi, Jackie.
Android and how to get the best out of it. So bye-bye for a couple of minutes. Bye-bye, Greg. Thank you so much. And